Hi, it's Katrina! From vegetarian crocodiles to a one-fingered dinosaur, here are 8 ancient creatures with strange features. Number 8. Atopodentatus Unicus. Atopodentatus Unicus was the earliest known herbivorous marine reptile. It was around 9 feet long and existed around 244 million years ago. The creature's name translates loosely to bizarre, unique arrangement of teeth. At first, all scientists had to work with was a poorly preserved skull. In 2014, they concluded that the creature probably had a zipper-like arrangement of vertical teeth contained within a drooping, flamingo-like snout or beak. They theorized that this beak-like feature was used for hunting and eating invertebrates along the seabed. However, these hypotheses proved to be false. In 2016, researchers from China, the United States, and Scotland announced a new theory based on 2 recently discovered fossilized skulls in the Chinese province of Yunnan. The findings, which were published in the journal Science Advances, describe the skull of Atopodentatus as a hammerhead and similar in shape to a vacuum cleaner attachment. At the top and bottom of the skull's wide front edge was a bank of chisel-shaped teeth that were used for scraping plants and algae off the sea floor. Then, the creature sucked the resulting matter, which was suspended in the water, into its mouth. A second set of teeth, which were needle-shaped and placed around the hammerhead and the narrow part of each jaw, acted as a filter by retaining the food as the water was pushed out. Pretty cool, huh? Number 7. Naturally nocturnal synapsids. That's kind of fun to say. For a long time, scientific theory held that animals being nocturnal developed around 200 million years ago as an evolutionary strategy among early mammals for avoiding dinosaurs that were active during the daytime. It was also believed that being active at night enabled mammals to survive the mass extinction that wiped out the dinosaurs. When scientists determined that nocturnal practices predated the existence of mammals by over 100 million years, it challenged their theory that nocturnality evolved as a defensive strategy against dinosaurs. Lizard-like creatures known as non-mammalian synapsids roamed the Earth long before any furry animals, and by analyzing the eye sockets of their fossilized skulls, researchers realized that they were creatures of the night. The study, which was published by paleontologists Kenneth Angelsick and Lars Schmitz in 2014, revealed that nocturnality may have evolved multiple times throughout the evolutionary history of synapsids, and that it was periodically lost and gained by various lineages. Nocturnality existed among the earliest synapsids, which means that it may date back even further, and that a single common ancestor of all synapsids may have been nocturnal. While many modern mammals are nocturnal, until recently, experts were pretty sure vertebrates hadn't started out that way. The 100+ million year discrepancy with their previous estimate of when nocturnality began reminds us that when it comes to learning about the prehistoric world, a lot remains unknown, and sometimes even the experts are left with no option but to speculate and hope for future discoveries that will lead them closer to the facts. Number 6. The Ichthyostega. The Ichthyostega is an extinct genus of animals closely related to modern-day 4-legged land vertebrates known as tetrapods. Fossils of the creature dating back to the Devonian period, or about 370 million years ago, have been found in rocks in eastern Greenland. As one of the earliest creatures to leave the ocean and crawl onto the land, it possessed a combination of fish-like features and traits that would later be found in amphibians. Ichthyostega weighed about 50 pounds and had the head and tail of a fish and bred in the water, but unlike fish, it had limbs. Its limbs were jointed fins with leg and toe bones, and it had 8 toes. The 5-foot-long amphibian-like animal had both gills and lungs and could breathe air, but spent most of its time in the water because its short, stocky limbs weren't really strong enough to support its body for very long. When on land, it lacked the necessary range of motion to walk and most likely moved very slowly, scrunching up its body and pushing itself along with its limbs, much like the modern-day amphibious mudskipper fish. And now for the Longisquama, but first, be sure to subscribe and let me know your favorite prehistoric animal in the comments below. Number 5. The Longisquama. This prehistoric animal belonged to a prehistoric subclass of reptiles known as diapsids. It lived between 230 and 240 million years ago, shortly before dinosaurs came into existence. The only known fossil of the creature, which was found in Kyrgyzstan during the 1960s, shows feather-like features, yet the first feathered dinosaur didn't exist until 70 or 80 million years later. Paleontologists have put forth several theories for explaining this. Some believe the specimen was a typical reptile that died among plant fronds, which have been mistaken as feathers. Others think that the feathers were real, and that today's birds may have evolved from feathered reptiles rather than feathered dino birds. The newest and perhaps most credible theory was presented in 2012 by Dr. Michael Bachwitz of the Freiburg University of Mining and Technology in Germany. He asserts that the strange appendages are neither feathers nor scales. During his reanalysis of the fossil, he noticed that the base of the structures were very close to the animal's bones and spine, suggesting that they were embedded deeply into its skin. However, although feather-like in structure and appearance, they possess distinct differences from fossilized feathers of the same period and that were found in the same area. For example, while feathers vary in structure depending on their length, these structures do not. Bachwitz believes that the strange body parts were linked to the early evolution of dinosaur and pterosaur fuzz, and that they were likely generated from the same developmental genes that feathers eventually developed from. This may mean that the reptile was part of the lineage that pterosaurs, crocodiles, dinosaurs, and birds evolved from. However, having a single incomplete skeleton to work with makes it difficult to draw any concrete conclusions about the animal, and for now, our knowledge of the Longisquama is limited to theories. Number 4. Casea. Casea was an herbivorous non-mammalian synapsid that lived during the late Permian period, around 255 million years ago, and possessed a round, pig-like body, short, stumpy legs, and a tiny head. The goofy-looking early reptile had an overhanging upper jaw with peg-like teeth, but no bottom teeth. It grew up to 4 feet in length and weighed up to 200 pounds. Because of its primitive teeth, Casea was unable to properly chew its food, but its intestines made up for this by being equipped for the complicated digestive process. The animal's odd proportions can be explained by its expanded rib cage, which served to allow room for a large plant-fermenting gut and big lungs. Because of its paddle-like limbs, some scientists believe Casea was semi-aquatic. On land, it moved rather slowly due to its oversized body. Number 3. Albertonectes Vanderveldei. I'm not quite sure how to say this, so we're just gonna go with it. Most mammals, including giraffes, have 7 cervical vertebrae. In other words, regardless of length, the necks of most species are supported by 7 bones. This was not the case among dinosaurs. It wasn't unusual for a species to possess more than 7 cervical vertebrae, as in a lot more. For example, the Apatosaurus had 15 bones in its neck. In 2012, researchers Ty Kobo, Mark Mitchell, and Donald Henderson identified what they believe was the animal with the highest ever vertebrae count. Their findings were published that year in the Journal of Vertebrate Paleontology and detailed a newly discovered long-necked plesiosaur. Plesiosaurs were a diverse group of air-breathing marine reptiles that thrived in the world's oceans for 160 million years during the Mesozoic period. Despite missing its head, the skeleton, which was discovered in a 70-year-old rock formation in Alberta, Canada, was nearly complete and measured 37 feet long. Its neck was 23 feet long and consisted of an astounding 76 cervical vertebrae. They named the species Albertonectes Vanderveldei. The previous record holder was another long-necked plesiosaur called the Elasmosaurus, which had 71 neck bones. For many decades, paleontologists have been trying to understand the purpose of the extremely long necks of some plesiosaur species. Originally, it was thought that they used their necks to rapidly strike prey, similarly to how snakes attack their targets. However, scientists later learned that this was unlikely because long-necked plesiosaurs had stiff, heavy necks that were not very flexible and would not have allowed the type of movement necessary to hunt that way. At first glance, a long, heavy neck seems like a disadvantage for a marine-dwelling creature. Long necks in aquatic habitats make for slow swimmers because they create a lot of drag, and the especially long necks of some species, such as Elasmosaurus and Albertonectes, made it difficult for them to turn in the water. There was a possible upside to swimming with a long neck, however, and it may have been helpful for traveling continuously and in a straight line for long distances. Evidence of fossils indicate that long-necked plesiosaurs preferred open water environments, adding credibility to this theory. Number 2. Vegetarian crocodilians. It's hard to imagine such a thing as an herbivorous or even omnivorous crocodile, since they're known in today's world as one of nature's most dangerous predators, but several such species existed in the prehistoric world. In fact, crocodiles as we know them would have only accounted for a portion of the populations that once roamed the planet. For 100 million years during the Jurassic and Cretaceous eras, the Earth was inhabited by many more crocodilians than it is now, due to the now extinct Crocodilomorpha superorder. Unlike today's species, which are limited mostly to wetlands and riverbanks, they lived in numerous habitats both on land and in the oceans. And yes, some of them were plant eaters. One subgroup of ancient crocodiles, Notosuchians, lived on the supercontinent of Gondwana around 180 million years ago. There were two types of Notosuchians, one of which was extremely territorial and aggressive, and another that had become at least partially herbivorous somewhere along the evolutionary line. From there, dozens of omnivorous and herbivorous species developed. While it's unknown why a common ancestor of those species abandoned a strictly carnivorous diet, they were incredibly resilient and well adapted to arid and semi-arid climates. These Notosuchians even survived the mass extinction 65 million years ago that killed 90% of Earth's wildlife. Eventually, however, they went extinct, and the last known species disappeared sometime between 5.3 and 20 million years ago during the Miocene. Number 1. A one-fingered dinosaur. One of the most bizarre dinosaur species paleontologists have come across is Longisquama, which had an ostrich-like build and two stubby single-clawed hands. The small dinosaur, which had a femur length of just 7 inches and was no more than a few feet tall, was discovered in 2011 in Inner Mongolia and existed during the late Cretaceous period. Longisquama was one of several species that shared similar characteristics and made up a group called alvarezsaurs. Unlike its relatives, who had tiny but non-functional fingers alongside their single claws, Longisquama had just one digit on each limb, making it the first known one-fingered dinosaur. Scientists are puzzled about both the function of this trait and how it evolved. The most plausible theory is that alvarezsaurs used their downward-facing claws to dig for ants and termites. Although there have been no discoveries of preserved nests that were attacked by these dinosaurs, their claws resembled those of modern-day anteaters and pangolins. Therefore, it would make sense for Longisquama and other alvarezsaurs to have gone after these insects. Thanks for watching! Have you ever heard of any of these? Which one was your favorite? Let me know in the comments below, and come on over and say hi on Instagram. See you next time! Bye!